Welcome to all. Today is Engineering Mechanics Systematic Complete and Detailed course. This I wrote earlier, Engineering Mechanics class number 142. Now we are entering part 3, that is centroid and moment of inertia. For that it is lecture 1. See, so far Engineering Mechanics part 1, force, moment and resultant, 41 lectures uploaded. Lecture 1 to 41, simultaneously class 141. Then Engineering Mechanics part 2, equilibrium, types of loads and support reactions, 100 lectures uploaded. Lecture number 1 to 100. See, lecture number I give based on part. But this will continue. Class number, not 41, 42. See, it's not 41, 42. Okay, 42 to 141. Now, Engineering Mechanics class 142, part 3, lecture 1. This will go further. I think centroid moment of inertia, number of lectures will surely touch around 100. Okay. Now, this is information. I am removing this one now. Now, one small information from my side. As I announced earlier, for the complete course, see, this is systematic and detailed course in structural engineering. I am going to cover engineering mechanics. See, I told it is not only engineering mechanics, strength of materials and structural analysis, both determinate and indeterminate. This will continue one after the one. Now we are in engineering mechanics. Once I finish this centroid and moment of inertia, I will go for a last part, that is friction. Once that is over, I will go to strength of materials. Very huge chapter, very huge subject. Then further huge structural analysis. I will continue. These all are meant for general public to give complete structural engineering education. Nobody should be deprived of education because of, say, some financial problem. They cannot attend the classes somewhere by paying the fees. So no, follow my classes systematically. You will learn everything. And remember, it will not stop here. After engineering mechanics, strength of materials and structural analysis, I will continue further for RCC, steel and pre-stressed concrete, and furthermore like some bridges or some other design parts, and also advanced subject like matrix method and finite element method. I will decide it later. That I will continue. Same way. In the same way, I will conduct the course. And as I already see in the beginning, I have given, you go to the playlist. There you can see information and details of courses in structural engineering. What all course I am doing, first one uploading. It is not in this engineering mechanics. It is playlist. You have to see information and details of courses. There I announced my complete plan or future plan for structural engineering education. There I told notes are available. See, systematic and very detailed notes are available, of course, for some nominal charges. All details for the notes are given there. Details of the notes, see, you first go to playlist, click this one, information and details, then see further, you can see details of notes for the course for engineering mechanics, SOM and structural analysis. You go through, and those who want to get the notes follow the procedure. Now, I want to tell one more thing before I start. This every class I will not tell. Whenever a stage comes, I will announce it. I was running paid courses all these days. But recently, when I started this course, I decided just to give structural engineering education to everybody completely free of cost. So, therefore, it is a very noble cause, and it is not just briefly. You can see class 142, see previous class 141 class, how systematic it is conducted. And I am not running any paid courses now. The only paid course I am running is software. That's all. The software you cannot do, that is ETAP, SAFE or STAD Pro, that you cannot do in YouTube. So that is the only one, that's all. Every other paid batches are stopped. So therefore, I made an appeal. See, In the same way, information and details in this playlist, you see systematic and complete course for EM, SOM and SCA. I made an appeal. Your wholehearted support is required for me. I don't want to use the word support means financial support because I should have some income. But money is secondary, but still it counts. So I appealed for people to contribute liberally for the cause, for the channel. How to make the contribution, I written there. I written full details there, how you can make the contribution. So now once again, I appeal to everybody, whatever possible, you can make the contributions. It will help me and also it will give more energy and I can go for more and more free classes here. So classes will be always free only. I can cover much more than what I am planning now. And one more small aspect. In every video, actually I don't want to call video, you can see there, see share, etc. one button called thanks. I have not told earlier. You can see one thanks. That is called super thanks, where somebody who will go through the class and if he is happy and if he wants to, if he or she wants to support my channel, he can click that one. There, some denomination will come, starting from very small denomination. So those who want can click this thanks and accordingly you can contribute there also. It will first go to YouTube, then from there, after some deductions, it will come to me. Or those who want to make direct contribution, you can see here the details. That's all. Now I'll change over to our subject, Engineering Mechanics, class 142, part 3, centroid, moment of inertia, lecture 1. And today's class, I will make very attractive and informative for you also. Okay, I'll prepare for that one. Prepare means clean the board and start. Now, our part 3, centroid and moment of inertia, lecture 1. See, first centroid and later moment of inertia, where centroid will once again come. Okay, now, see, there are two terms called center of gravity and centroid. So many people, they take same, but actually difference is there. See, I will tell you, when weight is considered, that is for three-dimensional body. Like, for example, see, three-dimensional body, I will show you. Okay, 1 minute. Okay. Three-dimensional body, see here. Then the term you are using is center of gravity. I will give more explanation in the next class. Today I want to go for a beautiful demo for you. Center of gravity. Whereas when plane lamina or plane area or in structural engineering, very important, in structural engineering, cross section, then the term used is centroid. So centroid, center of gravity, you consider when weight is considered, that is for three-dimensional body. Centroid is for plane lamina. See, for example, if you write a note, this is three-dimensional. Here we consider center of gravity, where weight comes. Whereas, suppose member is here, you take a cross section here. See, you see a plane area. It is called a lamina. See? For that one, it is called centroid, that is cross section. Or if you take cross section this way, see, here. Or If you take cross section this way, suppose for example, again plane area, 2-dimensional. So center of gravity is for 3-dimensional, centroid is for 2-dimensional. In center of gravity, weight comes, here weight will come, weight considered, okay, leave it. Here weight considered, here only area considered. I will tell the importance, what is going on, not today. Today I will explain. I made a small model here to completely make you comfortable and get confidence. Some model is there. I prepared a small model, of course, edges are torn out. Little error will be there, experimental error. That we will ignore. And then I will tell you, if you want accurate answer, what to do, I will tell it later. So, now, this is actually 3-dimensional. See here, there is area and thickness. It is 3-dimensional. But if you consider only this one, plane area, it is lamina, that is 2-dimensional. So for entire body, it is center of gravity, whereas only for this lamina, that is plane area, it is centroid. I will tell it later. Now, first of all, brief definition. Next time I will give everything. Center of gravity for a body is that point through which weight of the entire body or total weight will be acting. Or, see, for example, I will tell you. Just for example, I will tell. Okay, some center of gravity I want. This will do. See, this is a 3-dimensional object. Inside the body, center of gravity is there. Now, if I suspend here, the weight will act like this. It will pass through center of gravity. If I suspend this way, again weight will act this way. It will pass through center of gravity. Or if I suspend a little inclined, see this way, then weight will act like this. It will pass through center of gravity. So the complete weight of the body, whichever is the position, whatever position you consider, where it will pass through, which point it will pass through, that's a common point. That is center of gravity. See, depending upon suspending, weight will have different lines of action. See here. I'll show you here. See, if I suspend like this, weight will act like this, vertically. If I suspend like this, weight will act like this, vertically down. If I suspend here, see, weight will act like this. If I suspend here, somewhere here, okay, weight will act here. So see here, the common point. That is inside, not here. Thickness also counts. That is center of gravity. Centroid is the projection of that point in the cross section, in the plane lamina, provided thickness is constant. If the thickness is different, then you cannot do that way. See, therefore, when the thickness is uniform, see, actually when you tell lamina, you take plane area, but for proving and to get the answer, you will imagine some small thickness, any thickness, T. Thickness is extremely constant, like see, constant thickness. So, the point through which weight of entire body will act, that is called center of gravity. By what weight it is attracted by earth gravity, center of gravity, and same way in the plane lamina, the projection of the point in the cross plane lamina, that point is called centroid. Furthermore, I will explain later. Now I will do one thing. I will give you a very convincing and satisfactory experiment, small experiment, to completely understand centroid and center of gravity. 1 minute. Model is ready. I will tell you. Now, today's class will be experiment. This will give you confidence. See, This is, see, you can see some thickness is there. It has got uniform thickness. Actually, wherever you see cross section is, this is same pattern. See, this object. What I will do is, see, there is a base here. Here, this way I will holding. 1 minute now. I will check how I am holding there. That also equally important. How much it is? 33 is where? Base is 29 I told. 29 base here. Yes, 29 base. So, this is 3-dimensional. See here. This is 29 centimeter. I measured little this. I have taken a knife and cut this what you call this object. I removed. But remember, there are some disturbances there. This is 29 centimeter. See, 29. And the height from this here, the height is 33 centimeter. I wanted 33 because later answer is 1/3. If I take 32, decimal will come. I cut it for exact 33. Okay, 33 centimeter. And these, see, when you take a triangle here, I would have taken this way. See, if this is 29, I would have taken half of 29 here, half of 20. Then centroid will come midpoint. This way, midpoint. No, I do not want midpoint. I want not symmetrical. So I made model so that this side is see, this way. If I project the point here, this is higher length, this is lesser length. So this length I mark at this point so that it is 20 centimeter. So from 29, it is 9 centimeter. Height is 33. Now, centroid will be, see, somewhere here is centroid. Actually, I will mark the red color now, centroid. See now, centroid. I will show it to you. This is the centroid. Where is the base? 1 minute. Yes, little this side. Okay. This is the centroid G. Okay, centroid G is here. And actually, if you go to center of gravity, it is inside. But same point, you have to go inside by half the thickness. If thickness is uniform, you have to go inside by half the thickness. See, this way we don't know. This you have to calculate now. This way we don't know, but this way it is half. That is in between. You see here, midpoint, that is center of gravity. But when you consider plain lamina, consider lamina here. See, plain lamina, this is G, the projection of that point into the plain lamina, that is centroid. See, center of gravity, which is inside, you cannot see it. But centroid lies in lamina. Now I will show you how centroid works. Okay, I will make a small experiment here, but there is some small problem is there. See, I used a weight. See, some weight I am using so that I want a vertical line. See, when you hang something like this, it will be always in a vertical line. It can't be going inclined. See, it will be always in a vertical line. Whatever you do. Now, see, little trembling you can see. So, there will be some experimental error. And one more thing. When I put a wire here, some friction will be there. See, freely, if I tilt here, see, if I tilt here now, see, if I tilt here, you can see here, 1 minute now, I will show you now. See, by chance, centroid is here, see. If I tilt this way and put it, see here now, it will come this way. See, it will come this way. The weight will pass through, see, if I draw a vertical line here, the weight will pass through G. Or, see, I made 4 or 5 holes here. And one more thing, because of presence of these holes, some area dispersion will come. So slight error will come. So if you want a perfect example, what you require is, you take a metal sheet, go to a factory, correctly cut whatever I tell. Then you take a thin thread, make a hole which is fully friction free, put oil, then suspend. Perfectly answer will come. See, I made hole number 1. See, I written here, hole number 1. I can see 1 here. See, I suspend here. You can see, weight is acting here. I suspend it to hole number 2. See now. See, now, again, weight is acting like this. I suspend to hole number 3. See now, tilted. Again, weight is acting. See, this point. Hole number 4, anywhere, see now, tilted. Weight is acting like this. Hole number 5, see now. Now, it is here. Or I will show you now, here I cannot put, see I try to make arrangement for suspending. In the classroom, not possible. And I have to, see when I put a line here, see, if I suspend here, the weight, see why weight required? Because otherwise the line will not be vertical. See, hole number 1, somewhere here, hole number 1, I will put a, we have little patience, you are learning. Okay, see here, if I suspend here, see, through hole number 1, see it is tilting. Now I should be careful, I should hold this way, see somehow you can see, freely. If I put this way, it will turn, see. Now my shirt is obstructing there, there should be no obstruction. See. Here, okay, see free. So if I suspend here, it is coming to, see, line is here. So draw a line if you want. Draw a line to that point. Okay, then suspend it to hole number 2. See, if you have a good arrangement, mechanical arrangement, smooth, a heavy weight plate, steel plate, you cut it and then see that the holes are very small and frictionless. The thread actually is very smooth, frictionless, and have an arrangement for free suspension. Perfectly you will get the answer. Here, because some error will be there. See, here now. If I suspend here, you can see it is passing here. See, I will draw one more line here. Okay. Then, hole number 3, I will suspend. See, here restriction is there, and I told you experimental error is there. Because here I am struggling to put it. Okay, 1 minute. You all learn hole number 3 somewhere here. Okay, I will put to hole number 3. See, it is passing here. Now see, draw a vertical line, tilted, freely if I put. See, same way, hole number 4. Hole number 4 is here. You know, hole number 4. Once again you can see some inclined way this way. Lastly, hole number 5. Sufficient. How many holes? You make thousands of holes every time that vertical line, that where the total weight is acting, will pass to same point. Hole number 5. See? Okay. Hole number 5. Therefore, you can see here now. See, there is restriction. Every time what happens is, all the times it is passing through one point here. See, little error will be there. Okay, now I want one thing. I will measure the distance here. See, I will measure what is this distance, and also I will remove this one now. What is this distance? I will measure using a scale. No cheating. Why should I cheat when I know the answer is coming? But decimal error is there because of it is not a smooth point, friction is there, little disturbance means it will become little tilted, and holes are made because of holes, area dispersion slightly changes, but no, ignorable. Now, if I see here, measure this point, I will project here, see. I will project here this point. I will measure here. In centimeter, around 16.3 or 16.4, in the range of 16.3 or 16.4, lies between, see, I am getting around 16.3 to 16.4 centimeter. Now this I don't have to measure. It has to come how much? 29 minus 16.3 is 29 minus 16.3 means 12.6 to 12.7 or 12.6. If it is 16.3, it is 12.7. If it is 16.4, it is 12.6. And I'll measure the height also. Height I can measure easily. Where is it? Where I kept it? Where I kept it now? Just now it was in my hand. Here. I was wondering. Height. Perpendicular to measure. This intersection point. Oh, it is almost 11. Almost 11. Maybe 10.9, 11.1 error is there. It is coming 11 centimeter. Okay. Therefore, I will tell now. So therefore, I will make this I got now. See, what I will do is I will put here 16.3, that is 12.7. Or instead of 16.3, if you take 16.4, that is 12.6. 12.6. This is 11. This is position of centroid we got here. But actually center of gravity is, see, this is centroid. This is centroid because it lies in the plane lamina. Structural engineering, we always want centroid. After next class, once I explain center of gravity and derive equation, then center of gravity we will never consider. Complete structural engineering, centroid. But sometime in a hurry, centroid, so many people what they do is, instead of calling centroid, some people call center of gravity. Both are same. But actually, weight, volume, three-dimensional means center of gravity, plane cross-section or plane lamina or area or cross-section, it is centroid. Symbol is G only. Here also G, centroid, G, gravity. Okay. Now, this is the answer we got. Now, I will do one thing. I will tell you something. 1 minute. I will clean the board and tell you. Okay. Now, someone will ask, okay, sir, you told everything, but how to believe it? Okay, how you know, how you can calculate it? Okay, wait 1 minute now, make a note here, leave it, don't see there. Note. Little later, maybe class number, lecture number, I don't know, maybe lecture number, maybe 5 or 6 in that, I don't know, 4, 5 or 6 somewhere there, we will discuss centroid, that is G, centroid symbol is G, for a triangular lamina. Lamina, general means, see, there is one triangle called right angle triangle. It's a particular case. Or also isosceles triangle. Here, see, here or here. This is a particular case. General means random triangle. General means random. See, at that time, we will put a sketch here. This way, I will do random, bigger I will put. See, make a note. I will make, see, in case of triangle, if these two are equal, your work becomes easier. Why? Symmetry comes here. CG will be here. No. I will go for random. After that, you will come here. This is easy case. So there, I will write a sketch for you. See, I will write a sketch here this way. I will call the base of triangle is B. You write here B. And somewhere here, is bigger here, correct? Okay. Here, this is dotted line. This is the vertex. I will take A point here, B point here. I will take C. This is a random triangle we will consider. One side is small, one side is bigger. And I will call this is base B, and this I will call height H. height h. Then these are not equal, subdivision, see what I will tell is full base is b. We will prove it mathematically. See, this what I am writing, we will prove it mathematically. We will prove it, not give the formula. After proof, I will put result. First we will prove it by, we will consider integration, etc. Is there or anything? We will prove it and then I will give you final result. The result will be, see, this distance from here to here, these are not equal. I will call this as B1 and B2. Here I call B1, B2, but structural engineering I call AB later. Okay, there is no B, it will be L0, loaded length. Don't worry now. Now, I will tell at that time, centroid will be on that side where area is more, this side. And height-wise, it is near to the base. I will give formula for centroid. I will write, this is the centroid here. The formula is, see little down, 1, 2. Okay. This is the centroid. I will tell at that time, this is centroid G. Then I will tell, if you measure the distance of centroid from the base, this distance will be 1/3 of h. We will prove it, and then I will tell, this is, see here in this case, vertical distance. Whereas if you mark the centroid along the base, this distance and this distance are given by, this distance is full base B plus this cut length here, B1 divided by 3. And from here distance is full base B plus this cut length B2 divided by 3. This one and this one we will prove in the class. It is mathematically proved. It is not a formula. It is not a thumb rule. Okay, now do one thing. Consider this one with that one. Your h will be equal to 33 centimeter right here. Now write one more sketch. You write one more sketch and tell, if I refer to the model, h is 33 and your B1 equal to 20 centimeter. And B2 equal to how much? 9 centimeter. Then your 1/3 of h will be 1/3 of 33. 33 equal to, y calculator, 11 centimeter. Right here. Oh, same answer we got here. See here, experimentally we got same answer, 11 centimeter. Then this distance will come, I write here, okay. This distance will come, where right now, space is not there. Okay, I write here, this distance will come, 1 minute, camera I should check. I am going below the line, otherwise full class wasted. Hope it is, oh yeah, space is there, okay. That distance will come, if you substitute in the formula, see, full base 29 plus this small cut base, I will tell cut base, full base plus this side distance, 20 divided by 3. You calculate it. See, there is no cheating. So far I never bothered. I know answer will come. Of course, the experimental error will be there because of so many reasons. See here, this is edge just torn, perfect length, see somewhere perfect length is not possible. And when I hang here by a thin thread, little disturbance will be there. So that you avoid by taking a metal sheet, correctly cut this size and put oil to the hole, small hole, suspend without any disturbance and then drop a vertical line. See there, my guarantee, it will pass through this point. My guarantee. Okay. Now, if I calculate, it is 29 plus 20 divided by 3 is coming 16.33 centimeter. And this is coming, which one? This distance is coming. What is full length? Full length is, full base is 29 plus that side cut length is 9 divided by 3, that is coming, divided by 3 is 12.67. Oh, right here. Oh, see here. We got within error. If my reading is 16.3, 16.33, 12.7, 12.67. Or if by chance error is there, if it is 16.4, little error, see, 16.33, because of this error, experimental error. So therefore you can tell this is the correct answer. Correct answer. So cancel this one. So 16.3, 12.7. You got here also, see, 16.3, full base 29 plus cut base 20 divided by 3, 16.3, and full base 29. That side cut base 9 divided by 3, 12.67. Therefore, remember, in structural engineering, if we write a result, it has got a proof and it is truth. There is nothing wrong, except some empirical formula we are using in RCC or steel or pre-stressed concrete or design field. We use empirical, but in engineering mechanics, even support reaction also, you can apply a load, attach a spring. By reading the spring reading, you can check the reaction also there. So later when I get, see, I told you, I want to have some more instrument here. I want to change over to an electronic board, but that is expensive. So I will wait when I get good contribution from people, and I will go for electronic board also. Then I can prepare some slides and also some demo videos I can prepare. So many things, but it will take some time. But right now, basic understanding. So right now, what experiment we did here for centroid is perfectly tallying. Therefore, very happy. At least you tell, oh, later you tell here. When I write the formula, if it is height h, this is 1/3 of h, and here it is b plus b1 by 3, that is b plus b2 by 3. You should tell, yes, we know the first class, it is proved experimentally. Theoretical proof will come in class number 4, 5 or 6, I don't know. I will first prove for rectangle, no proof, triangle, it will come maybe class number 3 or 4 it will come. Or before that I may do some examples and then go to standard proof. I will prove for what, right angle triangle, isosceles triangle, general triangle, then circle, semicircle, quadrant of a circle, arc, some arc portion, everything, and then built up sections, everything will be covered here systematically. Once you understand complete centroid, then you will change over to moment of inertia, where centroid will come. Remember, number of classes will surely, I know, go beyond 100, because so much information I will give you, so that one who will study this chapter from me in his life, wherever he requires, he will have complete control centroid and moment of inertia. For that matter, I will see that if you attend all the classes and study thoroughly, you will have complete control on structural engineering. How much effort I put, you utilize it. And again, I make a request once again. So many are not bothered much. You are using these classes. You share it to reach more and more people. Spread it in the groups, professional groups, etc., colleges all, academic places all. See that my class will reach maximum possible. See, then I get more motivation. If views are lesser, what happens is feeling will come. People are not, I know, one fine day, views will go very high. But it will take some time. You see that it will not take some time. The time has come for my effort to be known to everybody and let everybody use the opportunity. Okay, thank you. Next class, we'll go for centroid and then moment of inertia, systematic way. We'll start. Today is only a demo. Okay, thank you.